figure out what the antiderivative of this is, and then just apply the FTC. Seems reasonable. Okay, so supposing that we go to do that now, what you are really doing if you want to do option 1 is you are first answering the question, what is the antiderivative of 2 cosine 2x? Okay, so let's answer that question. What is the antiderivative of 2 cosine 2x? It is just sine 2x, but being a little bit explicit about it, I am defining a new function u, and I don't usually do this, but this time I'm going to do it. I'm going to think of u as actually like a function temporarily. Just like go with me on this. So I'm defining u to be 2x. It's just the same thing as before, but I'm just writing a little bit different. I don't know why. And what is the derivative of u? Well, the derivative of u is just 2. But we usually don't write that. What we usually do is we write du dx is 2. And we don't even do that, right? We usually just write du is 2 dx. It's all different ways of writing the same thing. Just stay with me. Okay. So the 2 dx is already perfectly there, and thus this just turns into cosine u du. In other words, I used u substitution to simplify my antiderivative, and then what is the antiderivative of cosine?
No sine.
It's just sine, right? So this is sine u plus c, but really I don't write it as sine u plus c. I should write it as sine 2x plus c. And hence, I have solved the problem. Everyone cool? Most of you just did that in your head with your experience. Okay, so that having been sort of solved as a side project will now be used, potentially, this is one way of doing it, by applying the FTC. And the FTC says that if you know an antiderivative, then this is just going to be, well, it's just going to be sine 2x, evaluated at pi over 2 and pi over 4. So just do that, tell me what you get.
It has 30 minutes of battery left.
Oh, good.
But there's like less than 30 minutes of class, so it's
good.
Ben,
So
Ben.
sine of pi is 0
Ben.
and sine of pi is 1. Do you guys get -1 as your answer?
Yeah.
Okay. All right. So congratulations. That worked out fine. Everyone's happy except for me, because I like option 2. And option 2 is to recognize that option 1 is kind of lame, because what we're doing is we're sort of doing a u sub to solve the antidifferentiation problem, and then subbing it back in, and then sort of subbing it back in again. What I want to push, and this is really the correct way to do this, is to apply the integration directly to the actual, or apply the u substitution directly to the integral. So suppose I want to integrate from pi over 4 to pi over 2 of 2 cosine 2x dx. So same problem. Now I'm going to do something a little bit different. I'm going to, normally I would just write u equals 2x, but this time, not to confuse you, but just because, I'm going to just be explicit that what I'm really doing is I'm defining a new function, u. And this new function u is defined in terms of x. It's just the doubling function. All right, and then we just take the derivative of u, just like we did a minute ago. We get 2. But again, that's really like the same thing as saying du dx is 2, and so du is 2 dx. All right, but now, when it comes time to performing the substitution, I'm going to do it directly onto the integral. In other words, I'm going to just say, well, okay, what is this 2 dx? Yeah, that's du. And what's cosine 2x? It's u. So this is cosine u du. And now, what are these numbers? Well, these are x values, and they need to be converted into u values. And how do I convert x values into u values? Using this formula. Exactly, you plug them in. So what is u of pi over 2? And what is u of pi over 4? It is kind of cool. What I'm doing is I'm just converting the integral directly into another integral, just in a different variable. But when I convert the variable which I'm integrating with respect to, I have to convert the limits of integration also. So u of pi over 2 is just pi, right? Yeah, and then this is just pi over 2. And now all I have to do is take the integral from pi over 2 to pi of cosine u du. And what is that? It's just sine u evaluated at pi and pi over 2. There's no subbing back at this point. I've just replaced one integral with another. And do I get the same thing? Yeah, I do, right? I get sine of pi minus sine of pi over 2. 0 minus 1.
Exactly.
No, it doesn't even say
They're very, very similar. I think I'm going to end with there's a visual there's a sort of possible to construct a visual representation of what's going on here. If you think about it, the deep claim that I'm really making here is that this integral, this original integral, is, according to me, the same as this integral. And this has a sort of obvious, there's a sort of obvious geometric understanding to this, because what is this function after all? This function is the one in which, let's see, the amplitude is stretched out by a factor of 2, but that 2 smushes the period by a factor of 2, right? So this is the integral from yeah, that's right. So this is I just want to make sure I graph this function correctly. It's a cosine graph, and it looks like this, right? Yeah. But I'm only going from pi over 4 to pi over 2. So pi over 4 to pi over 2 of this function, it looks like this. I think I'm passing trig right now. Yeah, that is correct. Okay, so intuitively, what is the area of half of a bump? We did this earlier today, right? One bump of sine or cosine is 2. So half of a bump would be 1. But this bump has been stretched out by a factor of 2 vertically, but also smushed by a factor of 2 horizontally. So it should still be 1, right? And so this integral is -1. Okay, so that was my original problem. This is a visual depiction of the integral from pi over 4 to pi over 2 of 2 cosine 2x dx. What I'm now going to make, please, or maybe you should make it. Please make a visual depiction of the integral from pi over 2 to pi of cosine u du. I get that, because that's like what cosine looks like, right? And is that also -1? Yeah. So, alright, so Robbie Fleischman, on some deep level, what I'm really doing when I do integration with substitution is I am transforming an integral into another integral via some function. And this u substitution is not just some cheap algebra trick, even though it kind of is. But a way to think about this cheap algebra trick is this cheap algebra trick is in fact a geometric transformation that one performs on the integral. And the transformation is that every x value is now, or every u value is now twice the corresponding x value. And so not only do I change the function, there's actually a lot of deep things going on, because since this is backward chain rule, it's as deep as the chain rule is. What's really happening is I'm sort of, by letting u be 2x, I am like performing a sort of horizontal transformation on the function by a factor of 2. But then I am also dividing the function by a factor of 2 because the factor of 2 is like the chain rule residue by which the like slopes have increased, and so I have to like undo that damage. And then when I change the shape of the function, I also have to change the limits to like match. I don't know, is this helping anyone? Whatever, let's do a problem. Here's a cool problem, it's like a little hard. Everyone right now, do the integral from 1 to 5 of x over root 2x minus 1 dx. Third period people at home, try this too. It's actually a little bit of a hard interval. And do it the new way, the option 2 way, because it's like the real way. What are you going to let u be? U equals 2x minus 1 works, right? And you have to actually do like a go back kind of style thing. U is 2x minus 1, but if you want to be cool, you can write it as like a function, because that's really what it is. U is a function of x. It takes x values and outputs u values. And this is one of those ones where I have to like solve for x, right?
Yeah.
X is like u plus 1 over 2 or something. I think I'm doing that right. So I need to put into, undo the damage. So it's like 1 over root u times x is like u plus 1 over 2 times du is 2 dx, so that's just du. You guys agree? Okay, but it is at this moment, as I am changing the integral from being an integral of x values to an integral of u values, I must change the limits of integration. This 1 and this 5 are x values. I need to make them u values. And so here, I just change this to be u of 5, and change this to be u of 1. Calvin, is that what you're going to say? To do? Question?
Pull out at a half from the u plus 1 over
Yeah, and then I have to like, obviously I have some more work to do here and stuff, right? So yeah, I can pull out a half, so this becomes like 1/4. Let's see, what is u of 1? Negative 1, right? And u of 5 is 9? Or it's just 1. Right, sorry, it's just 1, and that's 9. So this becomes 1/4, the integral from 1 to 9 of u plus 1 over root u du. And at this point, you don't look back, right? I'm not going to ever do any back substitution. I've now just converted that original integral to this new integral, and now I just do this integral, and then whatever the answer I get is the answer. So do this integral, how do you do it?
divide by
Split it up, yeah. Whoa,
Sorry, I got some stuff in my throat.
cool. Do whatever you need to do.
Yeah, like
So it's like 1/4 What was that? Yeah, I got that. Megan, back me up. What you got? All right, no disagreements.
I got a number.
Oh, you like finished the problem?
I think.
Okay. This is gonna be 1/4 times. If I plug in 9 here, I get 2/3 times 27. That's 18 plus 6 minus 2/3 plus 2. Did I do something wrong? Is that right? Okay, so did you guys get 26 minus 2/3 is a fourth? 26, that's 26 minus 2/3. I feel like something's wrong, but I'm not sure what. 4 times, maybe everything's fine. Is everything fine? Yeah. Okay, so that's like 60, 70, 76 twelfths? No. What the hell's going
Wait,
on?
no, that's 24 minus 2.
24 minus 2 is, oh, 20.
It's like 3/4.
Better?
No, 22.
Ah!
It's 22 because it's 24 minus that
26
2.
versus 24.
Wait,
Right.
no.
So it's 73rd.
18 plus 6 is 24. Minus the 2 on the right is 22.
Oh, so it's 22. So 66, that's 60. Oh, yeah. So it's 1/4 times 64/3. Yeah, this looks better. So, good. I can do math, I swear. Answer is 16/3. Is that what you got?
Yes.
Okay, good. Woo! All right. Let's see. What do we have time for? One thing, I suppose. More. Two things. One thing. Two things. One thing. One thing. Let's do one thing. Two things. You had this packet called. No, you didn't. I didn't give it to you yet. You had this packet. It is called Integrals and Riemann something. You remember what I said, everybody? And we're going to do the first one together. So, Taylor, here's what it says. It says the limit as n goes to infinity of, and then there's just like this weird 1/n thing, and then this is 1/n squared plus 2/n squared plus 3/n squared plus n over n.
Yeah, so don't
Okay. All right. Eric, this is just a limit. And this limit is a Riemann sum. Whoa. So this is another one of these, do you really understand what integration is? So that's kind of like the goal of this worksheet. But now, since we know the fundamental theorem of calculus, we can also do a bunch of integrals. So, this is a sort of a, I think it's a quite hard packet actually. It's on a theoretical level. You need to figure out what integral this Riemann sum represents. What? What integral does this Riemann sum represent? You guys understand the question?
No.
Does this look like a Riemann sum to you?
Yeah.
It kind of looks like a Riemann sum.
It's like
Really?
x squared.
Yeah, some people are just going to get this like immediately, and other people are going to have to struggle with it. So look, what does this 1/n look like to you, maybe? Does this kind of look like the delta x part to you? It does to me. And now here I'm adding up a bunch of things. What kinds of things am I adding up? Yeah, I'm adding like 1/n squared plus 2/n squared. Why might I be doing something like that? And ending with n/n squared. Yeah, so conjecture, maybe the function that I care about is x squared. And so what we have to do now is we're sort of reverse engineering the integral which would have led to this Riemann sum in the first place. Okay, and what would I be integrating from?
0 to 1.
0 to 1. Calvin, why did you know that it was from 0 to 1?
Because you end with n over n squared, which is just 1, and then it doesn't
Aha.
have any.
Yeah, he says we end with n over n. Maybe the first good question to ask is, how many terms are there in this sum?
N terms.
N, right? 1, 2, 3, and I stop when I get to n. So if there are n terms in this sum, then what I'm essentially doing is I'm going over to 1 over n, I'm going over to 2 over n, I'm going over to 3 over n, etc., all the way over to n over n, which he observes is just 1, and I'm plugging that expression into this function. And then I'm multiplying by 1 over n, and if I do that, what I'm really doing is I'm just finding the area under the curve from 0 to 1 of the x squared curve. Kind of do that one for you. Is that okay? So the first half of this problem is thinking about what's going on, counting how many terms, trying to figure out what the delta x is, and then understanding that this is just the integral from 0 to 1 of x squared. But then also, like, we know how to do that now, like, pretty easily, right? What is the integral from 0 to 1 of x squared? Which is?
1/3.
Don't do it. You guys
Yes,
have
you
way
do.
Well, sometimes I do, but sometimes I don't. Bullies. All right. So the answer to this limit is in fact
1/3.
1/3. Yeah, this is just a limit, and a limit, if the limit exists, is just a number. And in this case, it is a number. It's number 1/3. Okay, do the next one. It gets a little harder. That was like the easy one. Do number 2. This is all we're gonna do today. It's kind of sad. I'll see you guys tomorrow.
Can we not?
Yeah, we'll have a little bit of homework. What?
Thursday and Wednesday?
No. This week is weird. Today is like a half even day. Tomorrow's like a full even day. Then Wednesday's a half odd day, and Thursday's a full odd day. So I am going to see you guys tomorrow. There will be homework, but it'll be like not so long. And then I'll see you on Friday for an all period day.
Good afternoon, ladies
Do number
and
2.
gentlemen. Few announcements.
Don't stop talking just because fuss.
All
Oh, I learned something new last class.
Soccer must attend the Summer League
Community
tryout this Friday, May 22nd at 2:30 on
Yeah,
the
have your chair
stadium
for a
field. If there's any reason that you cannot attend, you must let
Put
Coach
this over the
Hayes know
speaker. You
before the
can
tryout
100%
date.
block out fuss.
Also, cheerleading tryouts begin
You're tall
today in the
enough. I
main
guess
shift
we don't need
at
to do it.
3:30. The boys JV basketball team will hold tryouts for the 2015 Summer League in the main
Wait,
gym
do number 2.
today, the 19th and the 26th. Tryouts for JV basketball Summer League will start at 5:30 and end at 7. Please see Coach Charles or Coach Pigram in the boys PE office with any questions. Boys Varsity League Summer League tryouts will be held starting today and tomorrow. Those tryouts will begin at 3 and end at 4:30. Please see Coach Pigram in the boys PE office with any questions. Good Blazers, there will be an open mic to celebrate the release of this year's edition of Silver Quill, Blair's literary magazine. Copies of this year's Silver Quill cost $15. See you on Friday, the 22nd at the open mic. The classes of Theater 1 and 2 have their evening showcase May 21st and 22nd at 7 p.m. It's a collection of new one-acts based on the comedy short stories of P.G. Woodhouse. It's for 2 nights only and it's free. A big congratulations to the Blair Allied softball team who
All right,
are
so
now
these
on
problems I like a little bit weird, right? How many terms are there? That's the first question.
Softball team members, if you should see them in the hallway.
No, there are not
Please
n
return all
terms,
overdue
actually.
library
How many
books to
terms
the
are
media center
there?
as soon as possible.
Yeah, it's like
All
1,
overdue
2,
books not
3,
returned will
keep
be
going
placed
all
on your
the
obligation.
way.
Pretty sure.
God,
Thank you and have a good
I
afternoon.
could have written this maybe as like plus dot dot dot, n over n to the 1/2, but then we keep on going until we get to 2n over n to the 1/2. Yeah, so there are 2n terms, so that's like a little bit weird, but that's okay, right? Whatever, n, 2n, n's going to infinity anyway. But then what appears to be the function?
X to the 1/2.
Yeah, x to the 1/2, but then what are we integrating from?
0 to 2.
Yeah, it must be 0 to 2, right? Because on the one hand, we're stopping at 2 because we just are. But on the other hand, if we have 2n terms and the width of the interval is 2, what should delta x be? What should delta x be? 1 over n. So it's all kind of like working out. So yeah, what we have is something that looks like this, and it's like 1 over n, 2 over n. But now I have, for the first time ever, I have sort of like 2n rectangles, if that makes sense. And so the answer is, whatever the integral from 0 to 2 of root x is, you have to just like do that.
How do I turn this off, Ms. Rose?
Yeah, then, like number 3 or 4 or something, right?
Yeah,
Number
Ms.
4.
Rose.
Yeah, then you need to fix it and unfix it. It's like what you're actually doing is you're performing undo the damage on the Riemann sum level. Yeah, most people are gonna mess that up.
How should I turn this
Yeah,
off?
check out what's going on.
How do I stop the recording?
Right, did you stop it now?
No, how do I do it?
Okay, oh, you just hit the red button again.